one. So let's say we have an example. So here are some a mystery animal. Here's a trilobite that were animals that lived in the ocean between 520 million and 540 million years ago. So that's something that we would use as an index fossil because for sure we knew when they lived. So if we were to find something nearby that, then we would use these. Well, let me put the question too. So here's the example. So what can a scientist learn from a trilobite fossil? I don't want it to be highlighted though. Okay, sure. So this would help with the age. But since we know how long ago they were, and if anything were to be found with them, then we can be like, okay, this must be something that was also 500, around 520 or 540 million years ago. The layer of rock. And trilobites. Trilobites look like that. They kind of look like the roly-polies that we see nowadays. So maybe paraphrase this big chunk. So otherwise you're going to have to copy down a lot. So the ones at the top were from yesterday. Or not yesterday, the day before. Let me clarify that. Unit 3 test review. I'm just going to add because one more thing because it's related. So what I briefly mentioned, index fossils scientists used to determine the age. But let's put that down on our notes too. So why would they do that? Yeah, I didn't mean yesterday. I meant last class. Yeah, last class we did the 3.3 review, the geological time. And then today we still reviewed 3.3. It's just now it's going to be for the test. So what makes the scientists choose which fossils to make an index fossil? So there are two characteristics that makes something a good index fossil. So one is that there's an unusual shape. Unusual shape. So it's kind of like unique. It's different. It can't be mixed with something else. So if you look at the trilobite, that has a very unusual shape. Not a lot of other fossils look like that. So it won't be confused with anything else. And the second one is that it can be found in many regions. So if it's not found in a lot of regions, they wouldn't be able to use it as much as a index fossil, right? Because with it being able, they were able to find the trilobites in a lot of different regions, so that it's a good index, and they can use it to determine, okay, if we see a trilobite, these other fossils must be also 520 million or to 540 million years ago, approximately. And jumping back to the time scale that we were talking about yesterday. Oops. So remember the most current era, that's what we're in right now, the Cenozoic era. the current era, and also known as the age of mammals, right? This is when mammals first started showing up. We're also a mammal, so maybe that'll help you remember that this was also the age of mammals. You can scroll up a little bit. I'm trying to squeeze this up in here. Okay, and then the other era that you would need to know about, the era right before us, the Mesozoic area, the era. So that's the age of reptiles. Nope. And it ended. I don't know why that keeps on coming back. It ended when an asteroid impact caused a mass extinction. This is like during the dinosaurs. So let's say, for example, the scientists found this dinosaur called Archaeopteryx, and they think it was similar to a bird. So, how would they support their statement? So, they made a hypothesis that this dinosaur is similar to a bird. So now they have to prove it. So, how they can prove their hypothesis is that they can examine fossils of Archaeopteryx and look for structures similar to those of modern birds. And if they are able to find one, that would help support their point. How do I spell this? It's a hard word. So yeah, basically every claim that you have, you need to find evidence that backs it up. Okay. Okay, I could have put this up earlier with the Mesozoic stuff, but just quick note that the Mesozoic era. Okay, well, I gave it away. So it's an era. So that's one thing you need to remember, that Mesozoic is another era, just like how Cenozoic is an era. Okay, and then lastly, just one more. Yes, I just have to paste it. So, important review from last class. Remember, the lowest layer will be the oldest. So these animals came first. And then this one's a little younger. This one's a little younger. So you might get like question asking based on this picture of rock layers and fossils, what two things can you conclude? And then you'll just have to look at the choices. Oh, so one thing I do want to know is that if two fossils like are right next to each other, they're the same age. And if they're higher up, then they're younger. Okay. I'll put the notes back up later, but I just want to show you a quick overview of what you'll be doing today. So I'll put the link. You'll get to work in groups. Let me pull it up real quick. And with all this fossil talk, it's our turn to be scientists. So with how old the Earth is, we'll have to find out. We'll have to do a lot of research to find out. So that's what you'll get to do. You'll get to do some research. You're gonna be scientists and answer questions with your group. So just overview, like what we said, like how do they know how the Earth is formed, or how long ago, how old everything that used to live here be, even though it's extinct. So all about fossils. They'll just use that to find out. So this is your explore. I'll be sending you like your group Google Forms list, not list, link. And you put all your group member's name. So your answer is how you answer is like down here. So pretend that. Click next. Okay. So how would I find this out? You can look it up on Google, but you have to find like a trustable link, right? So then your group members will decide if your information that you're getting, this the information that you're getting it from, that's a trustworthy link. Then you answer the next. So just a bunch of questions, and at the end, you'll be writing like a mini lab report. You'll be making a claim, and then you'll have to find evidence, like also researching evidence to back it up.